In this video, we'll be solving a rational inequality. A rational inequality is an inequality involving fractions. Now what I'm going to do is I'll show you the steps for solving a rational inequality on the left side, and then I'll do that step on the right side with this inequality. 6 divided by x minus 3 is greater than or equal to 4. So our first step is to rewrite the inequality, if necessary, so that 0 is on one side and there's a single fraction on the other side. So I'm going to subtract 4 from both sides to get a 0 on the right, and I have 6 over x minus 3. Subtract 4 is greater than or equal to, and these will cancel and I'll have a 0 there. Now I need a single fraction on the left side here, so I'm going to write this 4 as 4 over 1, and then I'll multiply top and bottom by x minus 3 so that I can get a common denominator and put these two fractions together into one fraction. So my fraction then has a denominator of x minus 3. In the numerator I have 6. And then I'll need to distribute negative 4 through this binomial. So negative 4 times x is negative 4x. And then negative 4 times negative 3 is positive 12. And then greater than or equal to 0. Let me combine terms and simplify a little bit here. My denominator is x minus 3, and I have 6 plus 12, so 18 minus 4x, and all that is greater than or equal to 0. Now my next step is to solve for values which cause the numerator or the denominator to equal 0. So let's do the numerator first. We need that to be equal to 0. So 18 minus 4x equals 0. Subtract 18 from both sides. These will cancel, and I have negative 4x is equal to a negative 18. Divide both sides by negative 4, and these will cancel, and x is equal to a positive 9/2, which is 4.5. And I'll use that for my graphing to determine my intervals. Then let's also set the denominator equal to 0. So x minus 3 equals 0. Add 3 to both sides. These will cancel, so x is equal to 3. And this is undefined, so I'm going to remind myself along the way that 3 is undefined. And since my original inequality is greater than or equal to, I'll include endpoints except this one. I won't include this one. Then we're going to use test values from each interval to determine which intervals form the solution set. So the intervals that I'm going to be working with, here's my number line. I have 4.5 and I have 3. So let me put 3 here and 4.5 here. So this interval is 1, this interval is another one, and this interval is another one. So step 3, use a test value from each interval to determine which intervals form the solution set. So I'll need to pick a test value from each of these intervals, and I'm just going to pick a number that's in this section of the number line. So basically a number which is less than 3 will be in this interval. So I'm going to pick 0. That's usually pretty easy to work with. Alright, then I need to pick a number that's in the interval from 3 to 4.5. So let me pick a test value of 4. And then for this interval, I need a number that is bigger than 4.5. So let's just use 5. So my original inequality was 6 over x minus 3 is greater than or equal to 4. So 6 over x minus 3 is greater than or equal to 4. I need to write that so I can see it. Now I'll put 0 in for x and see if this is true or not. So 6 over 0 minus 3, and I want to know if that's greater than or equal to 4. This is 6 over negative 3, so that's negative 2, and that is not greater than 4. So this interval does not work. From negative infinity to 3 does not work. So let me try a test value of 4. So I have 6 over 4 minus 3 is greater than or equal to 4. I don't know if that's true or not. This will be 6 over 1, and that is greater than 4. 6 is greater than 4. So this one does work. So this will be part of my solution. And then test value of 5. I have 6 over 5 minus 3, and I want to know if that's greater than or equal to 4. 6 over 2 is 3, so that is not greater than 4. So this one does not work. So the only part of my number line that works is this section in this interval right here. So I'm going to remind myself again that the 3 is undefined. I'll just write UD. And then depending upon how you're asked to write your answer, you may be asked to graph it. So the graph would look like this. We have 3 and we have 4.5 or 9 halves. We're not allowed to use the 3 in our solution, so parentheses. But the 4.5, since we have greater than or equal to, this line underneath the inequality means that I do include the endpoint when it's allowed. So I do include this 4.5 in my solution. So we use a square bracket for that. And then we want all of the numbers in between those two endpoints. So this is our graph. Our interval notation, if you're asked to show it with interval notation, pretty much looks just like the graph, only we don't have this number line part on it. It does not include the left boundary, which is 3, and does include the right boundary, which is 4.5. Or you may be asked to write it in set notation. Set notation would be the set of all x's such that, and x is between these two numbers, so we write that this way. We don't include the left boundary, but we do include the right boundary. So we have to use the line underneath the inequality to show that 4.5 is included in the solution set.